Okay, so the soil quality website is a house for a large data set that people can get on there and access a wide range of information about different soil properties across many regions of Australia. And part of the project more recently in the Soil Biology Initiative is to take this national. It was initially a West Australian program, and now it's a national program under the GRDC and DAF. And each state slowly is coming online, and you can see as you go in closer and closer, the sites become more and more apparent, and they're all situated there on the map of WA. And those highlighted little polygons, they're the different catchment regions, and they're the ones that have data inside them. But what you do is you go over to the right hand side here, and you can start to access and look at some of the data. So that takes you to a page, and obviously you're now in Western Australia, and on the right there's a whole series of measurements that have been taken for all the sites in the state. So you can click on a whole series of biological indicators, chemical indicators, which are ones we're probably more familiar with, things like pH, salinity testing, some of the constraints like boron, nitrogen, cation exchange. And then other basic physical indicators, bulk density for measurement of compaction and clay content. The important thing when looking at data is the way you group it. So what we try to do is split the data in such a way that it is useful to the person that's using it. So obviously at a state level, there's a limited amount of information from what you can get. You can have a look at the data, but it may not tell you that much. So what you can do is you can go further into the data set and maybe choose a region. So there's 5 regions in Western Australia, and now we're inside the Great Southern region. So that's obviously in this area of part of the world, and there's something like 300 sites, 280 odd sites there that we've measured. And you can start to group the data according to different data sets. So we've been to Kojonup, we've been to Cranbrook, Borden, and this data set is probably the largest one that we went to. This is part of the SCARP program. If we go into the Albany Sandplain, you get what we call a traffic light overview. And essentially what we're doing here is we're applying critical levels to each of the measurements that we do. So these are thresholds above and below which will start to impact on your production or impact on what you do on farm. So you can see here, there's a bit of red there. So we have a pH issue when it comes to this part of the world. We also have a massive water repellency issue, and we also have some compaction issues. So that highlights very quickly and neatly and succinctly that there are some issues there that we need to look at. Now salinity's been mentioned in WA, it's a big problem, but for this region it doesn't appear to be a big problem at all. And similarly we can do the same with other soil quality indicators. What you can do here is you can go and look at the data, then it'll start drawing some graphs. So there's a database behind here that draws the data out live. So every time you click on a new indicator, that graph is redrawn. It's not a static image. So there's a couple of things to note here. We're in the Great Southern area up here. We're on the Albany Sandplain, and we're looking at pH in the topsoil. And in this case, there's 260 sites that got measured here. So that paints a picture. Again, we've put the traffic light down here, so the critical values here for topsoil pH, in this case, are 4.8. Below that, you're significantly impacting on production. 4.8 to 5.5, obviously there's a little bit of an issue, you need to start managing it. Here you're in the happy region, and obviously there are issues when you get to high pH as well. Now that's looking at all the sites we went to. There are a range of land uses and a range of soil types there, so what we can start to do is say, well, let's break this down. Let's look at the land uses and how that's impacted on pH. So we've got crop soils, we can add a data set there and see what it looks like. So this tends to imply that the guys that have been cropping are looking after their soils and they've got a better pH than the rest of them. So that also it suggests that there's other guys in the area that haven't necessarily been looking at it. So we look at the next level down, which are guys that start to introduce animals into their system, and that draws another graph. And then we can look at the permanent pasture guys, and that draws another graph. So these are all on fairly similar soil types across the 3 regions. And what this is saying is that the permanent pasture guys probably haven't focused on liming as much as they should have. The difference there for the crop guys is that there's been a massive extension program around managing soil acidity in the west on crop soils, and these guys have been listening and they've been doing something. So there it highlights a problem. While the overall picture wasn't great for all the soils, it tells a different story when you break it up into land uses. So it's the permanent pasture guys that are dragging the population down, if you like, for pH. And you can do that and look at each one of the indicators in the same way. Carbon stock is very similar. This is what the project was about. And you can get a look at what the carbon stock values are like. So we can look at say, in a similar way, you can look at the carbon stock, which is what this study was about. So all that's doing is presenting a range there. Again, we're in the same area, looking at the same sites, measuring carbon stock from 0 to 30 centimetres. And what you can do is if I choose either end of the scale, so the crop guys obviously probably going to have the lowest carbon stocks. They're in the lowest rainfall area, so they're not going to be producing as much biomass. We go to the other end of the scale, the guys that have continual cover 365 days of the year. It splits them up, and obviously there's a marked difference between the 2 land use systems. Now there's complicating factors in there, in that rainfall is higher on the permanent pasture systems, but nevertheless it tells you a story. The next thing you can do is look at the data in a different way. So if you're involved in the project and you had data collected on your farm, you would want to know what that is. And so what we do for farmers is give them a code that is unique to that site, and they can then access it. So each farmer will get a code. I'll just type in a random one and see what comes up. Now I know that this is from the Murray catchment. This is the data set that was uploaded today. And what that's done is bring up all the data that was measured for that site. We've got some of the descriptive details. It's a sandy soil. It's collected last year. It's on the slopes region. It's a perennial pasture in a higher rainfall band. And there's the data. And it's all for that one site. You can click on each one of these, and it'll draw from the same data set that we've already had a look at, but it'll draw a different graph for you to look at. Now what this means, and it's all described up here on how you interpret the data, but simply for each one of these bars, this is the upper level, this is the lower level, so that gives you the total spread of the data, and then this is the middle 50%. So it gives you an idea of how tight the data groups, and then that grey bar is the median data point. So again, we've grouped data differently here. This is the actual point. So the value is about 29.9 tonnes per hectare. This is that data point all the way along. And what he's doing here is comparing himself, this farmer is comparing himself to all the other guys that were sampled and measured in the program, and they're on the website. So on a state level, on a regional level, so that's just in the Murray CMA, and on the grower group level, obviously these two, the state and region, are the same because Murray CMA is the only group at the moment. The grower group level, so comparing himself to all the other guys in the slopes, and what you can see is the spread, and this has been shown in the actual data, that the spread of data is slightly different in the slopes compared to the rest of the guys. All the guys in that soil texture, so we're looking at just the guys that have sand, and obviously as you expect, sand, poorer textured soil, doesn't have as much carbon storage, so the top of it's just been lopped off. Similarly with land use, we seem to have had a similar effect, although the median value is a bit higher. And in the rainfall band, you'd expect with higher rainfall, obviously you've got a higher upper limit, but because he's on a sandy soil, the rainfall's not enough to get him up into the remainder of the guys, so the people that have loams and clays. So that's a different way of looking at the data, and it provides an interpretation for the farmer who's had their data included. And again, you access these graphs in the same way as you did with the other bar charts. So acidity has been mentioned, pH is the same. You can draw the same graph. And you can say, well, there are guys in the state that have much better pH than I, but look, I'm above average. I'm above average across the board, except maybe for everyone in this soil texture, I'm a little bit lower. So it just shifts the data around and compares you to different people, and you can make interpretations on that. So that's the data. So that's how you access the data and have a look at it. But you really want to make an interpretation on that and get some information around it. So the fact sheets section gives some more information for those that are interested. Now there's a big database here of biological, chemical and physical fact sheets, and you can go in there and on a wide range of topics. Now they relate to various states, so microbial biomass in general, but specific to Queensland. You can click on this and it'll pull up an HTML version of the fact sheet. And there it is there, you can have a look at it and read it online. So these are the fact sheets. There's an HTML version and there's figures taken directly from the fact sheet. So it's all online, you can read it there, but if you want to save a version of it, take it home, print it, whatever you like to do, you can download a PDF. And we even have printed copies that can be sent out if you request them. So it's just a simple two-pager. It's not the full story on each of the topics, but it's designed, the website is designed primarily to be a conduit towards more information and investigating soil topics in general. And there are a few other things you can do on there. Obviously, we have there's a lime comparison there's various calculators that you can use, and you can enter things like the lime quality, which is something in WA that's very important for soil acidity. And you can enter in the lime quality. There's a couple of arbitrary ones put in there. You can compare the quality of the lime and how much it will cost to get it onto your farm. And even though in this instance, lime X is more expensive to get onto the farm, because it's got a better neutralising value, you're actually saving money and it costs less.